If the universe had been created with, like, absolute mathematical perfection, you wouldn't just be dead. You wouldn't even be a memory.
No, not at all.
Because in a perfectly symmetrical cosmos,
Hmm.
the universe itself wouldn't even have the capacity to remember anything.
Yeah.
It would just be this sprawling, infinite flash of light with no hard drive, no structure, and really no ability to process a single thought.
Which, honestly, it completely flips the script on how we normally view the night sky. Like, we tend to look up and just see the cosmos as this vast, quiet container.
Right, like a big empty box.
Exactly, just a giant passive stage where stars and planets just kind of happen to be sitting around. But that perfect symmetry you're talking about, it introduces a totally different framework, one where the universe is actually frantically and continuously working.
Well, welcome to the deep dive. We are taking a massive shift in perspective today, looking through the lens of some really fascinating source material, specifically the theoretical frameworks developed by Clinton Alden at the Cosmos Institute of Systems Theory.
Yeah, and it's some heavy stuff.
It really is.
Yeah.
The Cosmos Framework treats the universe not as a place, but as a colossal, active computational process. And our mission today is to use their research to explain one specific, almost impossibly tiny number.
Right, it's a parameter that physicists call baryon asymmetry, and the number is 6 times 10 to the power of -10, so 6e10.
Which sounds incredibly niche.
It does. It sounds like some obscure rounding error, but according to this theoretical framework, it is the absolute bedrock reason why matter exists. It's the reason you have a physical body, a planet to stand on, and, the sheer neurological capacity to process the words you're hearing right now.
We are going to connect what the Cosmos Institute calls Axiom 1 directly to cosmic processing and show you how a microscopic imbalance at the literal dawn of time is the only reason you are here.
Yeah, but to understand why 6010 is sort of this magic number of existence, we really have to look at the ground rules of reality that this framework sets up.
Okay, let's lay it out. Where do we start?
The foundation is Axiom 1, which they call the principle of computational existence. It basically argues that the universe instantiates a computational process. But the really vital word there is non-trivial.
Non-trivial, meaning what exactly?
Well, the universe isn't just passively holding information, it is actively transforming it.
Okay, so like a trivial computation would be, I don't know, typing the number 5 into a calculator and just hitting equals.
Right, you just get 5 back.
Yeah, in math, that's just an identity function. Nothing actually changes, nothing is gained.
Exactly. A non-trivial process, on the other hand, takes inputs and irrevocably changes them into totally new outputs. So the universe takes a cloud of primordial hydrogen, applies the crushing force of gravity, and outputs a star.
Wow, okay.
Then it takes the radiant energy from that star, hits a planet's surface, and outputs chemical reactions. It's constantly crunching data, turning one physical state into a completely new physical state.
I love that. So if Axiom 1 is the processor, like the cosmic CPU that's just constantly churning through these state changes, then it immediately runs into a wall without the second rule, right?
Right, which is Axiom 2.
The principle of persistent state. Because, you can't run a complex software program if your computer just completely forgets everything it did the exact millisecond the calculation finishes. You need RAM. You need a hard drive.
That is a perfect way to put it. Computation fundamentally requires a persistent, addressable state. The Cosmos framework defines this mathematically by saying, basically, there has to be a physical substrate where the current state is directly built on prior states, and it has to hold its shape for a measurable duration of time. In physics terms, it needs a non-zero relaxation time.
Meaning the data doesn't instantly evaporate into thin air.
Right, it has to linger long enough to be acted upon again. Because without a physical medium that can hold a memory of the previous calculation, like my CPU you mentioned, it's just spinning its wheels in a void.
It would just process an input, instantly lose the result, and have to start over.
Exactly. Non-trivial computation is totally impossible without a substrate that remembers.
Okay, I follow the logic there. A universe absolutely needs a hard drive to build complexity. But let's look at the actual physics of the early universe for a second. If we rewind the clock 13.8 billion years to the Big Bang, we don't have hard drives. We don't have atoms or stars or carbon or anything. We just have this blindingly hot, infinitely dense soup of raw energy. So where does this required memory bank actually come from?
Well, that tension is exactly what the cosmos theorists call the catastrophe of perfect symmetry.
The catastrophe of perfect symmetry.
Yeah. Because when we look at the raw energy of the Big Bang cooling and condensing into physical matter, standard physics basically dictates that it shouldn't just produce matter.
Right, it creates pairs.
Exactly. Energy condenses into pairs. For every single particle of matter created, an identical particle of antimatter is also created.
They're like perfect mirror images of each other. And when matter and antimatter touch, they annihilate each other entirely, just turning right back into pure energy.
Which creates a catastrophic problem for Axiom 1 and Axiom 2. Because if the Big Bang produced exactly equal amounts of matter and antimatter like perfect symmetry, every single proton would have instantly collided with an every electron with a positron. They would have perfectly canceled each other out.
Leaving a universe filled with absolutely zero matter. Just a massive, endless void filled with light, like a photon bath.
A pure photon bath. And from a computational systems perspective, a photon bath is mathematically trivial.
How so?
Let's think about the physical nature of a photon through the lens of relativity. Photons travel at the speed of light, and relativity tells us that as you approach the speed of light, time actually slows down for you relative to the rest of the universe.
Wait, so if you were actually traveling at the speed of light, time just stops entirely?
Yes. From the reference frame of a photon, it experiences absolutely zero proper time. So it gets emitted from a star and hits your eye, and from its perspective, those two events are exactly simultaneous, even if it traveled through space for 1 billion years.
Wait, let me just try to wrap my head around this.
Yeah.
Because a photon doesn't experience the passage of time, it physically cannot hold a memory.
It cannot undergo a state change. To have a memory, you basically have to exist in one state at time A and maintain that state into time B.
Right.
If you don't experience time, your persistence, that ability to hold a shape over a duration, it effectively drops to zero. A photon can't act as a memory block because it just has no temporal duration to hold the data in.
That is wild. It's literally a universe that gets factory reset every single Planck second. The ultimate cosmic amnesia.
Yeah, and it also lacks addressability. Like in a pure bath of light with no matter anywhere, every photon is completely indistinguishable from every other photon.
You can't tell them apart.
No, you can't index them. You can't find a specific piece of data because there are no physical landmarks to point to. You only know a photon is even there if you have a material detector like a telescope or an eyeball to absorb and measure it.
But in this perfectly symmetrical universe we're talking about, the material detectors all annihilated themselves right at the beginning.
Exactly. So a perfectly symmetrical universe annihilates into photons. Photons cannot hold memory. That violates Axiom 2. And without memory, you cannot have non-trivial computation, which totally breaks Axiom 1.
So the whole thing just blue screens.
Yep. The entire system crashes into a trivial, endless loop of light doing absolutely nothing.
So to prevent that total system failure, the universe fundamentally required a glitch. It needed a physical error in that perfect symmetry, like a leftover, unannihilated chunk of matter that survived the initial explosion to act as a cosmic scratchpad.
Yes. Non-trivial computation essentially demands a matter-dominated universe. The KOSMOS Framework proves that an asymmetry, having just slightly more matter than antimatter, isn't just some weird quirk of physics. It is a strict prerequisite for existence.
That honestly reframes everything physical around us.
Yeah.
The desk I'm sitting at right now, a drop of rainwater, the physical structure of a cell, it isn't just stuff that happens to be here. It is the persistent, addressable state required by Axiom 2. Matter is just universal RAM.
It is the substrate holding the calculations.
But okay, if we need this leftover matter, this asymmetry, to exist at all, it begs a massive structural question. Why did the universe leave behind the specific amount of matter that we see today? Like, if it just needed some scratch pad to write on, why couldn't the error be much bigger? Why this incredibly specific parameter of 6E10?
Well, answering that requires moving from the basic necessity of matter to the mathematics of how a system actually optimizes itself.
Okay, lay it on me.
The KOSMOS Framework introduces Axiom 3, which is the principle of optimization. This principle dictates that a universal computational process will naturally evolve its foundational parameters to maximize its long-term computational potential.
So the universe isn't just trying to compute, it's trying to get the highest possible score. It wants maximum complexity for the longest possible time.
Exactly.
But how do you even measure a universe's score?
The sources outline this theoretical model called the equation of existence. It calculates this overall potential, which they represent as the Greek letter phi as the product of 3 competing factors.
Okay, what are the factors?
The number of processing units, multiplied by the lifespan of computation, multiplied by the computational diversity.
Okay, let's pull those apart a bit.
Yeah.
The number of processing units would just be the raw amount of leftover matter, right? The asymmetry parameter itself.
Yeah, the raw material, the baryons, the protons, the neutrons, the physical hard drives, like you said earlier.
Right. And my instinct here is that more is always better. Like if you want maximum computational power, you want as much RAM as possible. So a huge asymmetry, leaving behind a massive amount of matter, should naturally yield a higher score.
You'd think so. But that's where the other two factors in the equation push back, acting as really severe constraints.
Ah, okay.
Let's look at the lifespan of computation, which is the duration that complex structures can actually interact. If you increase that asymmetry parameter too much, you end up with an incredibly dense universe that is just overloaded with raw matter.
And when you have that much matter packed together, gravity becomes the absolute dominant force.
Right. Everything just pulls towards everything else incredibly fast. The universe would rapidly collapse into supermassive black holes almost immediately after the Big Bang.
Wait, let me challenge that for a second. A black hole is one of the most dense collections of matter in reality, right?
Sure.
So if matter is our cosmic hard drive, wouldn't a universe filled entirely with black holes just be the ultimate data storage center?
I mean, it is fantastic at storage, but terrible at active processing. A black hole basically locks information away behind an event horizon. It's essentially read-only memory that you've thrown away the key to.
Oh, that makes total sense.
Yeah, you can't have interactive state changes between different systems if all the data is just trapped in these disconnected gravitational wells. So the lifespan of complex interactive computation drops to almost nothing.
So an overload of matter is basically a cosmic game over.
Yeah.
The hard drives just crush themselves.
Exactly.
But what if we go the other direction? What if the error in symmetry was much smaller, leaving only a tiny, tiny sprinkle of matter?
Then the opposing force takes over, which is the expansion of space. If matter is too sparse, gravity can never overcome that outward expansion. Those isolated atoms of hydrogen just drift further and further apart.
So they never clump together to form gas clouds.
Right. And gas clouds never gain the pressure to ignite into stars.
You get a universe that might exist for trillions of years, checking the box for lifespan. But absolutely nothing structurally complex ever gets built.
Exactly. Think of it like trying to build a massive, intricate sandcastle. If the sand is completely dry, which is analogous to a universe with barely any matter expanding way too fast, it just blows away in the wind. You can't stack it.
Right.
But if the sand is entirely soaking wet, analogous to a universe overloaded with matter, it just slumps into a dense, muddy puddle, a black hole.
I love that analogy. You basically need the exact right level of dampness in the sand to build the towers and the arches. You need a tension between the forces.
Right. And when the cosmos theorists map this tension mathematically, they calculate the absolute peak of that potential function. They find the exact point where you maximize the amount of raw processing units without triggering a gravitational collapse, while still providing enough density to form stars over billions of years.
And that mathematical peak
Is roughly 6 times 10 to the negative 10.
610. So out of the unimaginable chaos of the Big Bang, for every 10 billion particles of antimatter that were created, there were 10 billion and 6 particles of normal matter.
Yeah.
They annihilate each other in this massive flash of light, and only those 6 survive.
And when you scale those 6 leftover particles up across the entire volume of the early cosmos, you get roughly 10 to the power of 80 baryons, which is the total sum of all visible matter in our universe today.
It's the perfect dampness of the sand.
It really is. It provides the physical substrate to give us 13.8 billion years and counting of complex interaction. But this brings us to the third crucial factor in that optimization equation.
Right, computational diversity.
Exactly. The universe doesn't just want a long, monotonous calculation. It wants rich, layered processing.
Okay, so a low amount of matter gives you incredibly simple physics, just isolated atoms bouncing around. A high amount gives you the dead-end processing of black holes. How does 6E10 specifically create diversity?
Well, because that specific density allows for different modes of computation to emerge and essentially stack on top of each other. Like at the most foundational level, you have quantum computation subatomic particles interacting.
Yeah.
And because the density is at that exact 6E10 sweet spot, gravity can gently pull these particles together over millions of years to form stars.
And a star is really just a giant cosmic forge.
It is a localized engine of atomic computation. The crushing pressure in the core of a star literally forces simple hydrogen atoms to fuse together, outputting entirely new, heavier elements. like carbon, oxygen, iron.
Which gives us the next layer. Because you can't have chemistry with just hydrogen.
Right. Chemistry is molecular computation, but it only works if those heavy elements forged in stars are distributed into environments where they are close enough to actually share electrons.
Oh, wow.
If the matter density of the universe was slightly lower, those elements would just drift apart in the vacuum of space, never interacting. But at 6e10, they cluster into planets, oceans, and atmospheres, where atoms are physically forced to mingle, share electrons, and form complex molecules.
And once you have rich molecular chemistry, you hit the ultimate threshold.
Yeah.
You cross over into biological computation.
Exactly. Cells processing environmental data through DNA, organisms reacting to stimuli, sensory organs feeding information into neural networks, brains processing memory and logic.
And then those brains dig silicon out of the ground, refine it, and start building artificial neural networks. Technological computation. So this number, 6e10, isn't just about ensuring there are enough rocks floating in space.
No, not at all.
It is the exact mathematical parameter required to stack quantum physics on top of stellar fusion, on top of chemistry, on top of biology, on top of technology.
It is the mathematical peak of the universe's ability to express information. If that symmetry error was, say, 5e10 or 7e10, that towering a stack of diversity completely collapses. We lose the chemistry, or we lose the biology, or the stars themselves just never form.
Man, let's bring all of this home and trace the entire journey we've just taken through these sources. Because we started with the baseline assumption that the universe was basically just an empty room waiting for things to happen.
And the Cosmos Institute shows us that the universe is actually a rigorous, self-optimizing engine.
Right. To even satisfy Axiom 1, to exist as a system that actively transforms inputs rather than just passing them through like a trivial calculator, the cosmos desperately needed Axiom 2. It needed a persistent memory.
And because perfect symmetry would have resulted in a timeless, memoryless flash of photons that couldn't hold a physical state, the universe required an asymmetry. It required matter to act as that substrate.
But guided by Axiom 3, the principle of optimization, the universe couldn't just have an arbitrary amount of matter. It tuned itself to balance the raw material against the threat of black hole collapse and the isolation of rapid expansion. And the result of that optimization, the absolute peak of cosmic potential, is 6e10.
That tiny imbalance is the mathematically mandated parameter for sustaining universal computation.
I really want you, listening to this right now, to just internalize what that actually means for your daily life. Every single atom in your body, every neuron firing to process the meaning of these sentences, every memory of your childhood you hold on to. Your entire capacity to experience reality relies entirely on that exact microscopic imbalance of matter over antimatter at the dawn of time.
You are the universe successfully computing itself. You are the result of 13.8 billion years of optimization designed to reach this exact state of biological and technological diversity.
It just completely shifts your entire relationship with the cosmos.
Yeah.
But before we wrap up this deep dive, there is one last concept from the Cosmos source material that perfectly caps this off. And I'll warn you, it's a thought that will probably keep you staring at the ceiling tonight.
Yeah, Axiom 4, the principle of substrate-process duality.
This axiom pulls the camera way, way back. It basically states that any computational process acting on a substrate can, in turn, become the substrate for a higher-order process. It is endlessly recursive.
Think about the ladder we just climbed. The 6e10 asymmetry built the atoms. Those physical atoms were the substrate that allowed for the process of chemistry. Then, the complex process of chemistry became the physical substrate for the process of biology.
Right, and the physical process of biology, the neural pathways in our heads, became the substrate for our conscious minds.
And the recursion theoretically just continues upward.
Which leaves us with this final, genuinely staggering question. If the dead matter of the universe built the physical brain, which allows for the localized process of your conscious thought, what higher order, completely unimaginable cosmic calculation is our collective human consciousness currently becoming the substrate for?
Yeah, if Axiom 4 holds true, human thought and our technological networks are not the end of the evolutionary line. We're just the new memory bank. We are the new hard drive for whatever the universe is calculating next.
The universe isn't just an empty room where stuff happens. It's an active machine. And we aren't just the audience watching the show. We are the hardware running the code. Thanks for taking this deep dive with us. Keep processing, and we'll catch you next time.